In this Bio 181 video in chapter 2, we start with the key concept. Water ionizes or breaks apart into ions to form a hydroxide ion and a hydrogen ion. And we want to remember that a hydrogen ion is just a single proton. So you've got water, which is H2O. It breaks apart into a hydrogen ion and a hydroxide ion. So this is a hydrogen ion, the positive ion. The hydroxide ion is negative. When it split apart, the extra electron was donated to the hydroxide ion, whereas the hydrogen ion lost the electron. This hydrogen ion is just a proton. It is just a proton. So this, I could just write it as one proton, whereas the hydroxide ion over here, we've got oxygen, which is bonded to hydrogen, and the oxygen is really where we're going to find that extra electron. Okay. So why do we care about this? This is related to acidity, because an acid is a measure of the number of hydrogen ions in a solution, whereas a base is the number of hydroxide ions, or you can consider it as a decrease in the hydrogen ions. So an acid is basically looking at hydrogen ions, whereas a base is often framed as, hydroxide ions. This can be a little bit more confusing, so I'm just going to stick with looking at hydrogen ions for the most part for this class. So we're going to say a base is going to decrease the number of hydrogen ions, whereas an acid is going to increase the number of hydrogen ions. And pH, pH, okay, is actually a measure of acidity, or the math function is the negative logarithmic function of the concentration of hydrogen ions. All right. So the pH scale is logarithmic. A logarithmic function is something that is going to change really, really quickly with orders of magnitude. And so if you look at a function, like if you were to graph it, logarithmic scale, something that's going to change really, really fast. Right? It's going to go exponential growth or decrease. With logarithmic function, the important thing for you to know is that every time, so the pH scale goes from 0 at the bottom, the lowest number, to 14 at the top, and 7 is neutral. So an acid, the strongest acid is 0, and the strongest base is 14. If you go from one number to the next, you're actually going to change the concentration of hydrogen ions by a factor of 10. So if you go from a pH of 7 to 8, you are going to change the hydrogen ion concentration 10 times. So logarithmic scale, this is log base 10. If every unit change, you're going to go 10 times. Now, because the logarithmic function is negative, just by definition, that means that as you go to a higher pH, you're actually gonna have less hydrogen ions in solution. Okay? So if you go from pH 7 to pH 8, you're going to decrease the hydrogen ions by 10 times. If you went from pH 7 to pH 9, it would be 100. And it would be a 100 times decrease in hydrogen ion concentration. All right, buffer. So the last concept here is a buffer. So buffers stabilize living systems by resisting changes in pH. This is really important because, as we'll learn later, biological molecules like proteins won't function in a wide range of acidity. They will break down. So it's important to keep things in a narrow range. And so say you have, I'm just making a graph here. So say this is, yeah, I think I'm just going to skip, not going to do that. I'm just going to say that buffers stabilize living systems. So if you add X amount of acid, if it's a non-buffered system, so no buffer, you'll have a large change in pH. Relative. If you have with a buffer, okay, you are going to have a small change in pH. So this is really important in, again, living systems where say you have, some soil and you've got acid rain. If the soil contains a buffer, then you can have a fair amount of acid rain on the soil before you're going to see that soil become very acidic. So the ecosystem is going to be much more stable. Whereas if you don't have a buffer, this acid rain can disrupt the ecosystem very easily. In humans, we have a buffer system in our blood. If you hold your breath very long, you're going to have carbonic acid build up. And without our buffer system, that would be very destructive. So we have a lot of different buffer systems. All right, and that is the last slide for acidity.